Again, this isn't new news, and this is actually an older article from June 6, 2019, so almost a year old. Why there's more greenhouse gas in the atmosphere than you may have realized. This week brought news that atmospheric carbon dioxide, CO2, levels at the Mauna Loa Atmospheric Observatory in Hawaii have risen steeply for the 7th year in a row, reaching a May 2019 average of 414. We are now at something like 416 or 417 parts per million. It was the highest monthly average in 61 years of measurements at that observatory, and comes 5 years after CO2 concentrations first breached the 400 parts per million milestone. But in truth, the amount of greenhouse gas in our atmosphere is higher still if we factor in the presence of other greenhouse gases besides carbon dioxide. We find that the world has already ticked past yet another milestone, 500 parts per million of what we call CO2 equivalent, or CO2-E. In July 2018, the combination of long-lived greenhouse gases measured in the cleanest air in the world at Cape Grim Baseline Atmospheric Pollution Station surpassed 500 parts per million CO2-E. As the atmosphere of the southern hemisphere contains less pollution than the north, this means the global average atmospheric concentration of greenhouse gases is now well above this level. Well above this level. What is CO2-E? Although CO2 is the most abundant greenhouse gas, dozens of other gases, including methane, CH4, nitrous oxide, N2O, and the synthetic greenhouse gases, my God, what is that? Also trap heat. Many of them are more powerful greenhouse gases than CO2, and some linger for longer in the atmosphere. That means they have a significant influence on how much the planet is warming. So these other gases that we are not paying attention to, CO2 is the one we pay attention to. These other gases have much more warming power than CO2. Atmospheric scientists use CO2-E as a convenient way to aggregate the effect of all the long-lived greenhouse gases. As all the major greenhouse gases are rising in concentration, so too is CO2-E. It has climbed at an average rate of 3.3 parts per million per year during this decade, faster than at any time in history, and it is showing no sign of slowing. Here we go. Can you see this? This is CO2. This is CO2-E. Crikey. Or holy shnikes, if you will. This milestone, like so many others, is symbolic. The difference between 499 and 500 parts per million CO2-E is marginal in terms of the fate of the climate and life it sustains. But the fact that the cleanest air on the planet has now breached this threshold should elicit deep concern. I think the concern that was brought up in the movie Planet of the Humans, right? We're doing all these wonderful things in the way of technology, and yet here we are. We're doing all these wonderful things in the way of technology. You know, our wonderful world of green energy, and it's getting better every day. And I'm being facetious, but you know, it is getting better every day. However, even though it's getting better every day, this is what's happening. None of these are even plateauing. None of them are going down. They're going up at a higher rate every single year. Warming on the way. The Paris Climate Agreement is aimed at limiting global warming to less than 2C above pre-industrial levels to avoid the most dangerous effects of climate change, but the task of predicting how human greenhouse emissions will perturb the climate system on a scale of decades to centuries is complex. The best estimate of long-term global warming expected from 500 parts per million CO2-E is about 2.5 C. The best estimate. You got that right. But so far, since pre-industrial times, the global climate, including oceans, has warmed by only 0.7 C. This is partly because industrial smog and other tiny particles, here we go, together with aerosols, reflect sunlight out to space, offsetting some of the expected warming. What's more, the climate system responds slowly to rising atmospheric greenhouse gas concentrations because much of the excess heat is taken up by the oceans. So, two important points brought up right there. To see or not to see, indeed. Some of the warming that has been expected has been delayed because of the global dimming effect or aerosol masking effect, whichever you like. And the oceans have done a really great job because that has been their job. The oceans have done a great job of being a sink for CO2, soaking up all that CO2. So we haven't experienced the effects of the warming yet. However, the last time there was an El Nino, and that was 2016 and probably, flirted into 2017. We had incredible warming, incredible ice loss, highest temperature year yet, and lowest ice. 2012 was lowest sea ice minimum. But we had fairly large amount of ice loss in 2016. So what happens the next time we have an El Nino? What happens when this aerosol masking effect goes away, et cetera, et cetera. And we are seeing some of the masking effect going away because of the lack of air travel, because of coronavirus, because of lack of industrial activity. Some have posited that we're going to see even higher heating this year, and it's still not an El Nino year. The amount of heat each greenhouse gas can trap depends on its absorption spectrum, how strongly it can absorb energy at different wavelengths, particularly in the infrared range. Despite its simple molecular structure, there's still much to learn about the heat-absorbing properties of methane, the second biggest component of CO2e. Lots to learn, but things that we already know. That it's many, many, many more times a potent gas than CO2. Studies published in 2016, 2018 led to the estimate of methane's warming potential being revised upward by 15%, meaning methane is now considered to be 32 times more efficient at trapping heat in the atmosphere than CO2 on a per molecule basis over a 100-year time span. Considering this new evidence, we calculate that greenhouse gas concentrations at Cape Grim crossed the 500 parts per million CO2e threshold in July 2018. This is higher than the official estimate based on the previous formulation for calculating CO2e, which remains in widespread use. For instance, the U.S. National Oceanic and Atmospheric Administration is reporting 2018 CO2e as 496 parts per million. What's a few parts per million here or there? Graph below shows the two curves for the time evolution of CO2e in the atmosphere as measured at Cape Grim using the old and new formulae. Some greenhouse gases, such as chlorofluorocarbons, or CFCs, also deplete the ozone layer. CFCs are in decline thanks to the Montreal Protocol, which bans the production and the use of these chemicals, despite reports that indicate some recent production of CFC-11 in China. But unfortunately, their ozone-safe replacements, get this, guys, here's important information coming at you. Hydrofluorocarbons, HFCs, are a very potent greenhouse gas and are on the rise. This is what, I guess, what they're talking about, synthetic GHGs. Recently enacted Kigali amendment to the protocol means that the consumption controls on HFCs are now in place, and this will see the growth rate of HFCs slow significantly and then reverse in the coming decades. Did you know all that? So, again, Again, the graphs and charts and information and data showing that things are progressing and not for the better. Hey guys, remember to like, share, and subscribe. You can also support the channel at the links below: PayPal, Square, Patreon. Thank you so much.